Welcome back. My name is Darren Thomas, and I am the Director of Educational Research Techniques. In this video, we're going to look at fraud detection again using Python, and this time we're going to explore the use of the random forest algorithm for fraud detection. So let's see what we can learn. Now, random forest is basically where you're having something called ensemble learning taking place, where instead of having just one decision tree, which is itself its own algorithm, you have multiple, hundreds of decision trees all trying to make a decision, if you will, on whether or not a specific case is fraud or not fraud. And so because you're using multiple trees, like hundreds, perhaps even thousands, depending on how you set it up, this helps to make your predictions more robust, and you're not overfitting the model to just one particular tree. And so again, we're not going to go into all the details about how the algorithm works. Just keep in mind the reason they call it forest is because there's many trees, and random because all the trees have slightly different adjustments to them. So what we're going to do now is we're going to start by bringing in our needed libraries. We're going to do that in two parts this time rather than one part. So here are the libraries that we're going to be using to start off with. These are for the data preparation part. So we're just going to go ahead and run that. And then the next thing we're going to do is we're going to, of course, bring in our data prep stuff. So let me show you what this is going to look like. So you've seen this before in prior videos. What we're doing is we're loading our data in this first line of code here. Now this data location is a string for a location on my computer somewhere, so you can't see that part. And so we're going to load our data. And so then from there, as you guys remember from prior videos, our X values are going to be column 2 all the way to column 29. And remember, in case you forgot, this data is kind of nonsense data. Like the individual columns have no particular meaning. It's just made up data for the purpose of demonstration. And then after we make up once we pull our X values, we're going to convert them to an array because we need that for our data analysis. Then we're going to take the last column right here and set it as our Y values. The last column is going to tell us, or it's like the outcome variable, if you will, is telling us if a case is fraud or not fraud. And then we convert these values to an array right here. So we're going to go ahead and run this. All right, that looks good. And so now what we're going to do is I'll just show you real quick what they look like just for the sake of being thorough. So this is what our X values are. So these are all the different X values, and then just the Y. Notice how it's just one basic row of data because each one of those represents an instance or an example from our data set. All right. Now what we're going to do now is we're going to explore the data just a little bit to give you an idea of what's going on here. So we're going to see, okay, how many observations do we have? That's the first thing we're going to figure out. So you can clearly see in this particular example, we have 7,300. And so all we did was just calculate the length of the Y values basically. And so now we're going to try to figure out, how much fraud and non-fraud do we have? Again, this is just so we have an idea of the proportions of our data. And so this line of code is kind of complicated, especially maybe for beginners. But what I'm doing is I for I and Y if I equals 0. So in other words, if Y equals 0 is going to be counted as non-fraud basically. Then we count non-fraud very, very simply by taking our new object called non-fraud and say count, and this is basically saying if it's 0. And then we print it down here at the bottom. So go ahead and take a look at this. So you can see we have 7,000 values that are not fraud basically. And so doing some basic math, we can now figure out what percent of our data is fraud and what is not fraud. And so that's going to be found right here in this next cell. Hope you guys can see that. And so what we're doing here is we're converting our data to a float, and we're saying count of non-fraud. So that's going to be on top over the total observations, and that's going to be our object called percentage, and then we print it. So this is going to tell us what percent of our data is not fraud basically. All right, so you can see right there 95% of our data is not fraud. And so doing some basic math, about 4% of our data is fraud, and I could just probably do that by subtracting Oh, it doesn't work like that. Oh, it doesn't like that. Okay, I know what I got to do. Put it inside 100. Yeah, so about 4% of our data is not fraud, and that's the proportion. So as in most situations, the majority of the data, a huge amount of the data, is non-fraud. That's to be expected when you're dealing with fraud detection. Now we're going to move to our model development, and so we have to load some additional libraries in order for this to work. And so as I mentioned already, we're going to be employing random forests. And so here are the additional libraries we're going to need. Of course, we're going to need random forest classifier. We have to, of course, split our data into a training and test set. That's standard for machine learning. And then these last two are for the confusion matrix and the classification report. And we need these to see the accuracy and to assess the strength of our model using various methods: precision, recall, F1 score, accuracy, etc. So let me run this first. All right, we're good there. Now, a lot of this should be review if you're familiar with some of the basics of, training machine learning models. We have to split our data into a train and a test set. So we're going to create 4 different objects right here. 2 of them are X train and X test, and then 2 are Y train and Y test. So we're splitting our data. And so we're going to split this data using this data sets or objects we made earlier, X and Y. And the test size equals 0.3. This is telling us that 30% of our data is going to be set aside for testing. That's what that means. So 30% of the X values will be here, 30% will be here. And then 70% of the values will be in our training set. And then random state equals 0. That's how you set your seed in case you want to reproduce this results. So we press Control Enter. There's nothing to see, sorry. And now we can train our model. Again, there's not a whole lot to see when it comes to training the model either. What we do is we create an instance of our random forest classifier. You can set the seed if you want. I chose to. These numbers don't have to be the same. Just make sure you're consistent in terms of what you do each time if you really want to reproduce the values that you're generating. And so once we create an instance of the random forest classifier, we then fit our model to it using our training sets. X underscore train, Y underscore train. Again, there's nothing to see here. Just run it, but we're getting closer to seeing things. And so now we have to predict with it. All right, this likes to show up. Sorry, that's something new here. And so now what we're doing now is, now that we have a model and we have a sense of how we can predict things, we're going to use our test data to actually predict values. So, and then we're going to compare the values that we predict for to the actual Y test. So now what I'm doing here is I'm taking my my X test, so the 30% of the X values that I did not use, and I'm going to use those to predict. That's what I'm going to do because my model has not seen this data yet. That's why we're doing that. And of course, this is not a thorough example of how to use or to develop a machine learning algorithm. Of course, you want to probably train your data more than one time, obviously, and you want to set parameters and you want to do cross-validation. But for the purposes of demonstration, we're just going to streamline this process. So I'm going to go ahead and run this. Again, there's not a whole lot to see yet, but I can give you a quick little peek. So if I do this, so these are some of the values it predicted. It always gives you a little short summary. And so what we're going to do is take these predicted values and see how well they do against the actual Y values, the Y underscore test values we have. That's the next step in our experience here. So now we're going to do the last step, as I just mentioned, and this is going to have 2 parts to it. All right, so first we're going to see our classification report. That's this code right here. And so what this is going to teach us or tell us is various metrics that we need to know about in terms of how well our model is doing. So precision, recall, F1 score, and of course accuracy are the most common ones. And what we're doing here is we're using this function right here, classification underscore report, and we're taking our Y test values and comparing them to our predicted values. using like a crosstabs, if you will. And we'll see more about that in a second. The second part of this particular experience is going to be the confusion matrix, which showed you all the positives, true negatives, false positives, and false negatives from your data set. That's what we're doing right here. And so again, we have to use our Y test values and our predicted values. You can see right here, we give them names. Y true equals Y underscore test, and Y underscore pred equals predicted. And then we actually use or print the information right here. So let's go ahead and run this. All right, so here are the values right here. So precision is pretty good. These are all associated with predicting true and false, true positives, true negatives, etc. Recall, we struggle more with that, so I'll get back to that in a second. And the F1 score is kind of a composite of the precision and recall. The support here, this is kind of telling you like how many values you have in your data set. So we have 2,099 that were not fraud, 91 that were fraud. So if you add that up, that's about almost 2,200, give or take. And then down here, yeah, 2,190, excuse me. Down here we have the accuracy as well. These macro and weighted averages matter if you set specific parameters. We didn't really do that, so that's not going to apply. And so you can see, of course, we're always very accurate because there's so few instances of fraud. That's why. Now down here at the bottom, we have our confusion matrix. And so in the top left, you can clearly see the values for top left, true negatives. So 2,098. And then down here in the bottom right, we have the true positives. Up here in the top right, we have the false positives, and then we have false negatives down here. So one reason the recall is lower is because we're having a problem with false negatives. We're saying somebody is not fraud when actually they are. So again, recall will probably be something you want to tighten up. Again, it all depends on your purpose. But when it comes to precision, we're doing pretty good. We only have one instance of a false positive. In other words, we found a case of fraud that really was not fraud. So that's kind of what's happening right there. And so again, we're not going to go over the details of how to make adjustments to the models. That's kind of beyond the scope of this video, but this is kind of what's happening. And so what we were doing here is we were just using random forests compared to when we used logistic regression in the past. And so it might be appropriate perhaps to compare the various algorithms as a way to see which one is better, which one has various strengths and weaknesses. But you also have to keep in mind your audience. Your algorithm could be perfect, but if leadership cannot understand it, it kind of defeats the purpose, because ultimately they're going to be held responsible if something crazy goes on. So they have to make sure, you have to make sure they understand as well. So let's go back and review and wrap up this video. In this video, we had an opportunity to use random forests for trying to detect fraud in the data that we had available. So we started by preparing our data, separating the X and the Y values from each other. They must be in separate objects. Then we did a little bit of, superficial data exploration. How many observations do I have altogether? How many of them are not fraud? What percent are not fraud? And then we actually made our model. So we used our random forest classifier. We started by, of course, preparing our data by separating the train and the test sets from each other. We made an instance of our model. We fitted our model to the data that was available, made our predictions, and then we checked out our matrix using the classification report and the confusion matrix. All that was done. And so again, random forest might be a superior algorithm in your own personal research or coding compared to what we've learned in the past, which is logistic regression. But it all depends on the characteristics of the data and your ultimate purpose. So I want to thank you so much for listening. My name is Darren Thomas. I am the Director of Educational Research Techniques. Thank you again for watching, and you take care.